Three parallel lines theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. Here the two straight lines L and M are given, and we can make relation between the segments like UW by WY. Here UW by WY must be equal to Vx by Xz. Same, using the three parallel lines theorem, find the distance HF between Main Street and South Main Street. Like FGH are three parallel lines, and this is the line segment which is perpendicular to all the three parallel lines. So now we can see, because angle A, which is angle 1, angle 2 and angle 3 all are congruent, and you can see simply because the line which is the oblique line is intersecting all the three parallel lines, then angle 1, angle 2 and angle 3 must be equal. And now you can use the corresponding angles converse to determine that FE, GD and HC are parallel. These parallel lines divide the transversals proportionally, and we have to find the value of HF. So now the length between E and D is given, the length between D and C is given, the length between F and G is given, and we have to find the length HF. So for finding the length HF, we have to calculate the length HG. So now by the ratio of the line segments, HG by GF is equal to CD by DE, and also HG by 120 is equal to 300 by 150. So HG is equal to 240, and now HF is equal to 240 plus 120 is equal to 360. So by the three parallel lines theorem, we can simply find out the value of HF, which is equal to 360. So the distance between Main Street and South Main Street is 360 yards. Now the second method we can apply here. Write a proportion involving total and partial distances. Make a table to compare the distances, like for CE and HF. For CE and HF, the total distance CE is equal to 300 plus 150 is equal to 450, and HF we have to find, and the partial distance DE is equal to 150 and GH and GF is equal to 120. Then 450 by 150 is equal to HF by 120. So by the proportionality theorem, we can simply find the value of HF, which is equal to 360 yards. Now triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the segment of the other two sides. So now for this we have to see that here the CD bisects the angle ACB. So angle ACD must be equal to angle DCB. Then AD by DB is equal to CA by CB. Using the triangle angle bisector theorem, find the length of RS. So for RS, here PR is the angle bisector of QPS. Then QPR is equal to RPS. Then because angle QPR is congruent to angle RPS and PR is an angular bisector of triangle QPS, so you can apply the triangle angle bisector theorem. Use the fact that RQ is equal to 15 minus X. So now by establishing the relation between the line segments, RQ by RS is equal to PQ by PS, then 15 minus X by X is equal to 7 by 13, and after cross multiplication we can write 195 minus 13x is equal to 7x, and then simply we can solve for x.